Hello and welcome to another episode of Learning Kyma, my learning path to Kyma. In the last episode, we took a look at deploying Azure Functions to Kyma. So a function as a service offering, open sourced by Microsoft. And at the end of the session, we kind of asked ourselves, because the question came up, if we have functions as a service, or in general, if you have workloads, how do we scale that stuff in Kubernetes and in Kyma? So today we want to dive a bit into the area of scaling resources, scaling pods in Kubernetes, and especially doing that in an automated manner. So as you can already see, I have opened up the kubectl cheat sheet, where you can see we have an API that allows us to scale the resources within Kyma. That's not really surprising, because last time, or in the second episode, we scaled up by changing the deployment, by changing the number of replicas, and basically that's what's happening here. So we scale some stuff up from current to something else, and so on and so forth. But that's a manual way. So we have to scale up and we have to scale down in a manual manner. Now, if you take a look at the documentation of Kubernetes and search for autoscaling or autoscaler, you will stumble across the following page. The horizontal pod autoscaler. So what is that? Basically, it's exactly what the name says. So what we have is we have a scaler that reacts automatically in order to horizontally scale pods, so to create new pods, which is also described here within this very, very first sentence. And it's based on the observed load of the CPU, or on other metrics that you can define and provide. There are some restrictions, but that do not really touch us at this moment. So this is basically how it looks like. So we have the horizontal pod autoscaler that calls to the deployment, and this deployment thingy then scales up and hopefully also scales down all the pods. Now, there is one prerequisite, because the autoscaler has to get these metrics. It has to see if and how CPU is utilized by the pods, and if there are any limitations within the pod that kind of do not allow the pod to do more. Because as we learned in the second, or on the very first episode, there is no real limit on access for the pods for CPU and for memory. In principle, as long as the underlying cluster allows it, a pod can reserve as much memory, as much CPU as it wants. But that's basically not the idea if you do microservices, if you do functions as a service. So there is one prerequisite, and that has to be available within your Kubernetes, as far as I understood from the documentation. That was the word I was looking for. We have this Kubernetes metric server. And that's not there by default within a Kubernetes cluster, as far as I have seen. So this is something that we have to check within Kyma if it's there. Usually, the way to do that is to check if there is a pod, a service, or a deployment that matches the name metric server within the namespace of kube system. So I have here now a little command line. So I have the kubectl, I get all the pod services and deployments that are within the namespace kube system within my Kyma cluster. So now what happens, you will see that in a second, hopefully. It will return something or nothing. What's wrong there? So let's port it. Let's get simply all the pods in the namespace kube system. Okay. So I'm not allowed to get pods. Let's see if this is the same for services. I don't know why this took so long the first time. Yeah, so for my user that I've signed up with, I cannot list the resources, services in the API group in the namespace kube system. So this is something that the trial or the managed offering of Kyma, I would guess, prevents you from doing. Okay, so this is not the way to find out if we have this metric server in place. Now what we can do is we can call a command that's only there if we have the metric server in place. So what we will do is now we will do kubectl, then we do top, which is like the Linux top, so a list of all the processes. And then we will say I want that for my pods. So, okay, I have prepared something, so you can see that it's in the default namespace. So you can, as I did not specify namespace, it's in the default namespace. And you can see we have some CPU usage, we have some memory usage. Okay, that's fine. So the metrics server is there. So now, why don't we try out some scaling? And there is, and I really like the Kubernetes documentation more and more the longer I work with it. There is a walkthrough for the horizontal pod autoscaler. And here is before you begin, you see you have this metric server monitoring needs to be deployed, otherwise you will have a problem. And what this tutorial does is basically deploy a very simple PHP application that does some mathematics. And this mathematics is kind of CPU intensive. And what it does, it will deploy all that stuff to Kyma. So why don't we do that? So let's go to our Kyma system and let's add a new namespace. Let's call that PHP load test. We will create this namespace. As I said in the last episode, it takes a bit in order to get everything up and running in there. So we will not do the deployment at once, but we will take a look at what is deployed from this default package. So there is this YAML file. So again, we have a deployment. We have one replica that's set, and we have a container image that's hosted within this container registry. So it's a standard registry that we fetch. And we put in some limits with respect to the CPU in general and with respect to requests. So this is kind of the home turf of the metric server. It watches the CPU and then reacts if limits exceed if you have the autoscaler in place. And here we have then a service that's deployed in addition. So with some metadata, which exposes the port in order to make it available. As we all know now, Kubernetes per default does not have API rules in place. So this is something that we have to add in order to make PHP-Apache accessible via the web, and in order to do some load testing on that one if we have the Autoscaler deployed. So what we will do now is we will issue that command to our cluster, but we will specify the namespace. So we deploy it now to our, that was the wrong one, to our PHP load test namespace. So we have PHP load test, let's see, no typo, that's fine. So let's deploy it, let's see if we are lucky. Takes too long. Yeah, so that's kind of an error that occurs from time to time. If the namespace isn't really ready from my perspective, so I don't know how long that sometimes takes, but that's clear an indication that although we see it here, the namespace is not really fully accessible. The funny thing is, what I can do is I can do a get pod. And if I also specify the namespace, then everything is fine. PHP load test get pod. So it's kind of there, but it's, yeah, now it works. So no idea what's happening behind the scenes. But there is something happening. So if you run into that error, don't get too nervous. Everything's fine. So let's see. Yeah, the deployment is running. So we have now the deployment running. We have the pod available, and we have the service that is here. So what we want is now we want to expose the service. You don't like me today? Yeah. So PHP-Apache. We have PHP-Apache. That's fine. We allow gets here. Yeah. Yeah, let's put those ones in. No delete, no head. That's fine. We don't want to deal with authentication, so we create that one. So that takes a bit until it's in place, or not. Let's see. So we have the service running. This is running against an error. Now, why is this the case? Funnily, it's perfectly working. Also, the status is in error. Okay. Okay. That's fine. That's fine. That's a valid error. Because I have deployed something, I will talk about that later. Let's do PHP test and save it. Now it's okay. Yeah. So I went to the wrong API rule. That's right. So I have here now my PHP test. That's fine. Yeah. Okay. So, okay. Now we have the service accessible from the outside, so we can call it. And now what we want to do is we want to autoscale it. So what do we have to do? We have to create an horizontal pod autoscaler, which autoscales the deployment. So we have an autoscale, we say the deployment, we specify the deployment, and then we say what's the limit for the percentage and what's the minimum of, I would guess, replicas, and what's the maximum of replicas that we want to allow. And if this autoscaler is then deployed, it will hopefully autoscale. Let's see. So we have kubectl. Well, let's do some trick here. I will put that one here. I will put that one here. So we have kubectl. Then we want the namespace. We want it PHP load test, and we want an autoscale. So yeah, typing is not that easy. We want our deployment, and that's PHP minus Apache. And we want to have the CPU minus %. Well, I will set it to 40. I want to have a minimum of replicas of 1, and I want a maximum of replicas equals, let's say, 6. I don't want 10. So let's put that up. Okay, so the autoscaler is there. So let's see if we can already see it. Okay, so we have an autoscaler running, which is referencing this deployment. The current target. So this is the CPU that's currently in use. That's unknown. Because the autoscaler first has to aggregate some metrics that he gets. This is our percentage target. Okay, we have min, we have max, we have the age. We can now also do a describe. That's another interesting command, because this will give you some more content. So this will tell you when it was deployed. Yeah, it's already up and running. Okay, we already have 1% here. Okay, we have min, we have max. Yeah, that looks good. So the API was able to successfully calculate the replica count. Okay, recommended size. So everything is fine. Everything is in place. There are no events happening. So we already see that everything's up and running. So I prepared something if this would take some time, because that's really kind of depending. When I tried it yesterday, it took 5 to 10 minutes until the metrics showed up. This went quite fast. I'm really surprised that it already fetched it. Okay, so now what do we have to do? We have to put on some load here. And in order to do so, I put that one here. I installed a tool called load test. That's an npm library, where I say, please do 100 calls. Let's make them concurrent with a factor of 10. And then I want to hand over the URL. So here we have the URL. So here we have the URL. I will put that in. So let's see. And let's also see what happens to our pods. So let's take that one, move that here. It's not the nicest representation, but let's fire that up. So this will hopefully now send several requests out there, and let's see what happens. Yeah, the load is already getting up. So this shouldn't take too long. Oh, okay. So let's see. Yeah, it's still quite relaxed. So that was too short, right? Yeah. Okay. So somehow this didn't really refresh here, quite frankly. So what we have now is a scaling up of the pods. So I was in the right namespace, right? Yeah. So what we have here now, as you have seen, the pods have scaled out. So that did not fully scale out to 6 because there wasn't that much load. But as you could see, it scaled out in order to deal with the load. So so if we do describe HPA, I meant describe, yes, right. So let's do that one. So here you see now very clearly, I really have no idea why the get didn't fetch that. Yeah, no matter. As you can see, we have here some metrics. So we have 228%. So it had to scale up in order to meet the demands, and that was what it did. It scaled up, and here you have the last events that happened. So it brought everything up. Now let's see the CPU now got down because there are no more requests there. So now the horizontal pod autoscaler should start to scale it down. As you can also see here quite nicely, this was the first one that we deployed. This was then the last one that it reacted, and then in between there are some pods that have been spun up. Now, why isn't this scaling back immediately? And why isn't it doing that very, very flexibly? Well, I mean, that's kind of the idea. As far as I read from the documentation, there is some grace period settings within the horizontal pod autoscaler that you can influence. However, it is not unusual that you wait a bit until you scale down again, because if you have a quite large demand in requests, you do not want to scale it down at once and then scale it up again while pods are currently being deleted, and then they are spun up again, and then they are deleted again. So you want to smooth that out a bit, and that's why there is some grace period that is in place in the horizontal pod autoscaler in order to avoid this fluctuation of pods. So it will scale out quite fast, as we saw here. So that was kind of immediately. And now as the load went down, it will still have some pods also. They are not needed, but it will not immediately scale them down, because it anticipates that if there was quite a peak of load, I will keep the pods and see if I have another peak or if I can scale down. So yeah, so currently there are 6 pods in there. This now takes some time, to be quite honest. I don't know how's the grace period defined. I think it's 1 or 2 minutes until it starts to recognize and get the mechanics going in order to scale that down. But that's, I think, already quite interesting. So we can define an autoscaler And the autoscaler reacts in combination with the limits within our pod, so the resource limits within our pod, to the demand that is created, and scales up all the pods in correspondence to what we defined within the autoscaler. So we defined the CPU load, so the kind of percentage at which point it should scale up. And we defined the maximum number of pods to which it should scale up. So this is, I think, quite comfortable. I hope that at some point in time it also scales down again. So currently there is really no load there. Yeah, but it's also 3% is kind of the standard load. Yeah, so let's see if at the end of the session it has scaled down. It should scale down because, yeah, that's the idea of the autoscaler. So being elastic. Now, as this mechanic is taking place, we should ask ourselves, is this really what we want in all cases of workloads? And well, I think if we talk about some workloads, this might be fitting. So if the let's say metric is really CPU, that scaling absolutely makes sense. But what if we are dealing with a different kind of workload? So let's say we have this Azure Functions thingy, so that we tested here. That's not really making sense to have loads there, right? So maybe I said before there is some custom metrics that we can use. So it would make more sense to have the scaling not based on CPU, but based on the number of events that come in, because a function is triggered by events. And even if many events hit, I want to scale that out in order to make it happen. So, and there is something, and that's called KEDA, or KEDA. KEDA is a Kubernetes-based event-driven autoscaling. And what it does is it kind of adds an additional component to your Kubernetes cluster. And this one does not react on CPU load. So it fetches the events that come in, and then tell your autoscaler, your horizontal pod autoscaler, to react on the events. So it's kind of man in the middle, or however you want to call it, where you can drive the scaling of any container in Kubernetes based on the number of events that need to process. So that's kind of a different way how to act, how to scale. And I think that's the most feasible way when it comes to functions as a service. And KEDA is kind of the counterpart of Azure Functions. So if you have Azure Functions within your Kubernetes cluster and you want to scale them, usually it makes no sense to scale them on CPU. It makes sense to scale them on the events that are coming in. And that is where KEDA is coming into place. So you can then also deploy KEDA in your Kubernetes cluster and let it do the scaling. And it's kind of a very, very slim component, but doing one thing very, very well. So it, as described here, activates and deactivates the Kubernetes deployments, and it acts as a Kubernetes metric server. So it replaces or it extends the metric server as a custom metric server. and provides the horizontal pod autoscaler with the information that it needs. And there are some things that are really interesting. First of all, what events and sources are supported. So as we see here, we have a lot of event sources that we can use in order to make the scaling. So it's not only CPU now. We have Apache Kafka. We have AWS Kinesis Stream. We have SQSQ. Of course, we have Azure Blob Store, Event Hubs, Log Analytics, Service Bus. So all the event sources on Azure. We also have RabbitMQ, kind of a classical thingy. We have Nets. Nets is also there in Kyma for the streaming. And yeah, we have also the classical things like CPU. And yeah, that's quite some stuff that comes with KEDA out of the box. Now there is one further thing that's really interesting when it comes to, let's see if I find that. When it comes to scaling, yeah, that's KEDA is not only scaling pods based on events or deployments, but you can also run so-called Kubernetes jobs, which are kind of long-running one-time jobs that you schedule within the Kubernetes cluster. And that's also kind of interesting because let's say you have an event and this event triggers something that's really long running, like a machine learning or something like that in that area. Then you wouldn't want to do that within a pod, but you want to do that within a Kubernetes job. And that's also there out of the box within KEDA 2.0 that came out this week as I'm talking on the 15th of November here. That's also quite cool to have that here. So we have now something that's kind of a custom metric server that allows you to scale based on events, not on CPU usage. It allows you to react on a lot of sources of events that come out of the box, and you can extend them. KEDA is open source, as you can see up here. It's available on GitHub. And it also allows you to do some things that are quite fancy with scaling jobs. So that's really cool. Now let's see if we can get this stuff running on Kyma. And well, I have to say I tried it. And well, you will in a moment see what will happen. So I will now copy that one and apply this YAML file, which is kind of describing what should happen within the Kubernetes cluster in order to install all the components, deploy all the components of KEDA within our Kyma environment. So let's put that here. Let's put that here. Now this should deploy KEDA on Kyma. And well, this is again this strange error that I had before. I didn't have that the last few weeks. This shouldn't happen because now we are without any namespace. No idea why that happens. So this is really something I will contact the Kyma folks out there. And now this doesn't look like we deployed something successfully. So we have an error from the server which says forbidden. We are not allowed to deploy this special namespace, and it kind of seems that this custom resource definition seems to be the issue, because this KEDA deployment is a custom resource. So Now, why is that? So if we take a look at Kyma on help.sap.com and we take a look at the roles, and this is something that I mentioned in the very first session, I think. We have these two roles, and we have the admin, we have the developer, and we have some restrictions. And these restrictions exactly kick in now. So we have administrative rights, yep, except for the right access to add-ons configurations and Kyma system namespaces. So we are not allowed to dig kind of deeper than on top of the Kyma stack here. So we can deploy some things that are, well, not dangerous for the Kyma cluster, like an autoscaler, but we cannot deploy this custom metric server because it's a custom resource, it's an add-on configuration. Why is that? Well, my explanation, I guess I'm right, is because it's the managed offering, so you can do that within the self-hosted Kyma environment, but you cannot do that within the managed offering because, well, SAP is managing it. You can mess things up quite a lot if you do things in that area. And this is why currently the managed Kyma offering prevents you to do that. So yeah, that's something that we have to live with. So no deployment of KEDA, no interaction of KEDA with Azure Functions. Bad luck for us, but that's what it is. That's currently the restriction that is in place. That's, well, things happen at trial. So let's see what happened with our auto-scaling. And ta-da! We have only one pod left, and that's the oldest one. So let's, okay, that was the kind of extensive error message. So let's kubectl minus the namespace. We have PHP load test, and we have describe HPA. kubectl would be perfect. Oh, man, typing. It's too late, I think. So we have kubectl. Yeah, third try and managed it. Yeah, so here we go. And this is also what's hidden here in this very, very last line of events. So we have a rescale event from the horizontal pod autoscaler to a new size of 1 after it's scaled up to 6 because all metrics are below the target. As you can see, this took quite some time. So it took its grace period and looks like it is 5 minutes in order to check if the load does not increase again, in order to make not this nervous scaling up and scaling down. And then rescaled to 1 as expected. So that's cool. So, okay, let's wrap it up. What did we learn today? We picked up the last episode where we deployed Azure Functions. And yeah, let's go here and switch to the topic of how can we auto-scale our pods. We can scale it manually, as we saw here, via command line or doing a new deployment. But we want to do it automatically. And for that, we use the horizontal pod autoscaler. The horizontal pod autoscaler relies on the metric server, which is available within the Kyma cluster and which checks the CPU utilization. This CPU utilization is then fetched from the autoscaler, and depending on how you configure the autoscaler, which we did here, you define which deployment is targeted by the autoscaling, and what's the CPU percentage that is taken as the limit, and what's the min and max number of replicas that should be deployed. Yeah, and then depending on the load, it's scaled up and it's scaled down again. Now currently, when it comes to plain Kubernetes, that's the only way how to scale within Kyma. We also tried to deploy KEDA as an event-driven way, as a custom metrics server. This did not succeed because there are some restrictions with respect to the managed Kyma offering. Okay, so yeah, that was it for this episode. I hope I could learn something. I again learned a lot. I also learned now today that within Kyma, the API rules have to be consistent over all namespaces. I didn't know that because otherwise there is a conflict, which is now, thinking about it, quite obvious, because this endpoint is the same for all namespaces. So this one should be unique when it comes to the host name. Yeah, so that's something that I learned today live during the session. Yeah, that's it. Let's see what comes next. I would say in the next episode, we will dive a bit more into this thing of serverless, of functions as a service that are part of Kyma based on Knative. Okay, then I wish you the best and see you next time.